the project is inspired from audio animatronics, which is some attraction, but some of the attractions in Disney theme parks. So here's one of them.
Of the United States, and will, to the best of my ability, preserve, protect, and defend the Constitution of the United States, so help me God.
Ladies.
Okay, so this is an attraction in Disney, Florida, as well as in California, and I believe the other theme parks around the world which Disney has. It's an attraction which has all the 45 presidents, I guess. And they basically are not really robots which can walk, but they are sort of like manipulators. They're fixed to the ground, so they cannot walk, but they can sit and stand. And so what happens is in this attraction, a couple of them say something in their own, in the president's voice, and the show goes on. It's about 5 minutes long. Now, one thing you want to know is that all these movements which you see are not programmed by engineers, they're programmed by artists, and that's because the aesthetic quality of the movement is very important. If you give it to engineers, they will get the task done, but it won't really look aesthetic. So a robot like this has probably 20 joints, like a shoulder joint, a mouth joint, and so on. And the guys, the artists who are programming this has a big panel with knobs. These knobs are essentially potentiometers. So when you move the potentiometer, it moves one of these joints. And what you need to do is you need to choreograph such that there are knobs, and moving a knob moves a joint. And so something like this requires a lot of artistry, but it also requires a lot of patience, because you need to not only synchronize the movement of the mouth with the parts of the body, but you also want it to synchronize with the sound source. And if you don't get it right, then you need to start all over again. So the person who's designing this is tuning this knob, listening to the audio, and once he's happy with it, he's pressing record, which records the audio tape. And then when you want to play it in a theme park, you basically have a recording which goes on, and the robot which moves, and they're synchronized. So it looks like the person is talking, but in fact, it is actually recorded movements and recorded audio. Okay, so the project, this started off like an independent study where I had a student who made animatronic face of the president of university where I worked before this. That's Ricardo Romo. And
welcome to UTSA. Go Runners.
That was taking his recording and putting it behind this animatronic. And then he got some media publicity from that particular independent study. So then I went ahead and did a class project where there were 26 professors in the mechanical engineering department. I assigned a professor to the students and told them that they have to go to the faculty, take a photo, take an audio recording, and make an interactive animatronics. The same thing what you guys are doing for your project. So I think you can read the rules. I posted them and I'll talk about them in a bit. Here, I think we've used the students use a tilt sensor. So tilt sensor can sense the orientation. And in response to that, the animatronic does something.
Hello, welcome to UTSA Mechanical Engineering. Please pull me back down.
Yeah, so the tilt sensor is used to figure out its orientation. This is the dean of the College of Engineering.
Welcome to the College of Engineering. Birds up. One more time with feeling. Birds up.
Okay, so the mouth moves and the eyes move. Now, this is what I would expect you to do, which is you can make something out of cardboard, stick the right face, and here you go. But there was one team which went really a step further, and they actually made a cast. This is another professor. And they made a cast, and it was pretty well done.
And heat transfer is all over. Do the CEs, civil engineers, do they take a heat transfer class? No. Do the double E's? No.
Okay, there were like 40 teams, I think it was like pretty big class. It was 120 students, 3 or 4 in our team. And so it was a big class, and all of our presentations were done in the atrium. We'll have a similar presentations in the atrium, and I'll come to that. I had animatronics for myself too. It's in my office and I can get it some point of time if you're interested in seeing it. All these things which I've showed you are in that tiny link, tiny.cc RoboProf. You can watch the videos. I also provided you with the reports of all the 40 groups. They are in that link, but they're also on the handout I gave you. Okay, and I'm expecting you not to read it in one shot because it's a 7-page document, so read it in parts. So I give you the motivation. I just spoke about it. It's from the Disney Hall of Presidents, but the limitation of the Disney Hall of Presidents is that it's a very static attraction. There's no interaction, so you are going to make it more interesting by having interaction. Now, instead of having professors or presidents or that sort of thing, I'm just opening it up to put anybody you want as an animatronic face. If you make a celebrity or somebody who is known for saying fewer things, then that would probably be a better idea. Because remember, ultimately you're going to showcase this in the atrium, and so you want people who come and I'm going to, of course, invite many people. I want them to watch it and have fun, right? So you want to figure out a good personality. These are the design objectives. Okay, so hopefully some of these things are covered in the lab. So for example, sensors, actuators, something which we have not done so much, but it's coming in the last 2 labs. I've already posted the second to last lab, and then there'll be a last lab that will tell you about sensors, actuators. And there's also an entire month we'll spend on sensors and actuators. There's a little bit of 3D printing, which you already are probably doing right now. And then you probably know how to integrate things because you've done some things in the past. Okay, so specifications. What the minimum thing you want the robot or the animatronic face to do is to say something, right? Say some words. So that's kind of important. But then the things which makes it more interesting are the interactive part. So when you use a sensor as a modality in which the sensor uses to communicate. So for example, ultrasonic sensor would measure the distance. You could have a tilt sensor, which measures the orientation and so on. So you could use any sensor you want. That's the first point, is about the character. Try to take celebrity, ideally somebody who people know and can identify with. You'll be doing this in a group of 2. So you have access to 2 kits, which means you have access to 2 Arduinos. You can pull in the 2 kits. So you will have 2x of whatever sensors come in your kit. But then you're not restricted to any of all these sensors. You can, of course, go and buy more sensors or more actuators. Up to you. I don't limit you on the sensors. I just want to limit you on the microcontrollers. What I require is that there are two different sensors. Okay, that's important. You should have at least 2 sensors on the robot, and you should have at least 2 moving parts. And the moving parts usually move because there are motors. So you'll have to use at least 2 motors. And then you have a bunch of motors there. You have DC motors, you have servo motors, stepper motors. You can use any 2. If you want more, that's fine too. Okay. It's also mandatory that the mouth moves because the mouth is going to be doing the talking. So you want that to happen, but then you can use any other moving part. Okay, it's up to you. You can also be some part which normally doesn't move, like the nose doesn't move, but you could make the nose move, or the ears don't move, but you could make the ears move in your animatronics if it adds value to your animatronic, so to say, play. The chassis, this is like basically the support structure. I say don't get fancy, just take cardboard as in cardboard which is thrown here and there. Maybe you have packages coming from a vendor, Amazon boxes, that's fine. Just take those, use those instead of trying to do anything expensive. It's supposed to be something which is a prototype. It's not supposed to be a production level device, right? 3D printing, I want at least one part to be 3D printed, and it doesn't have to be too big. It can be very small, right? Joints, connectors, it's your call. You can power it externally by using 9-volt batteries, but you could also use you could power the Arduino from your computer. Now, what happens typically with this motor is that some of the motors cannot be powered by 5 volts, especially the bigger motors. So you might need to hook up a bigger battery, probably 9-volt battery. But if you can do it with your computer, that's fine too. Okay, then this should be autonomous. Remember that this is interactive, can interact with people. So you could use some of the sensors to start it. And I think I also allow you to use a joystick or a module, joystick module, or a IR remote to start the animatronics, up to you. But once it starts, the sensors, the modality of interaction should be in response to a sensor on board. The animatronics should talk and soundtrack should sync with the face. Okay, now this try your best, but I think for a good animatronics experience, you need it to be synced somehow, like it look realistic. So try to do that. Don't let the sound play separate from the movement of the face. Now, what I will do is you cannot. Now, I said this. You could potentially link this with the computer. That's one way to do it. You could use a computer speaker, but you might be better off buying a speaker and buying a chip which converts the sound source to an audio part. Now, what I plan to do is, and don't quote me on this, I'm trying to buy you a MP3 player and a speaker. A speaker is not available in your kit. It is a buzzer. So what I plan to do is I plan to buy enough speakers for the groups. So I think there are 12 or 13 groups. I'll buy one speaker, one MP3 player for each group. So that way you can do this without having to buy anything from Amazon or wherever, right? You can just use that speaker and you already have a kit with so many things. So you don't need to buy more things to figure this out. Now, if you want to make it more fancy, you want to add more sensors, then you got to go and buy. But I think I'll try to figure out how I can make it as cheap as possible for you by buying this number 9 for you. Okay, there'll only be one per team. Okay, two interaction modes. Okay, so there are 2 sensors, remember that. So there should be 2 interaction modes, as simple as that. This is more important. It's not really about building something, but I want you to really have fun. So just try to be creative. Just try to think of something funny. And sometimes you can make the animatronics say something in that person's voice, but which is obviously it's coming from a recording you find online. But feel free to change the voice to something else, like a baby voice or an angry voice, recorded voice, digital voice. That's fine. Just try to make it interesting so that when people come and visit this, when you're presenting it, it's sort of fun for people, and they're like, it's not something which they don't expect. Like I want them to see something or experience something which they don't really normally would expect from the animatronics you make. So try to be creative, and that would be, I would say, important. What I did for this time for the project is I want you to write the report as an instructable. An instructable is, I took this name just from the website, instructable.com. Instructables.com is a website owned by, I think, AutoCAD, where they have people giving instructions on, sort of build instructions, step-by-step instructions, so other people can create their device themselves. So I want you to document your work as an instructable so that, number one, people who look at this can use your ideas to create their own animatronics. The second thing, which I think is a huge plus for you, is that you can then go, when you go to the job market, if you think that this is worth presenting to your interviewee, then just feel free to show it to you and sort of on the web, so you can easily show it. So I think that it will help you a lot, not only for your job hunt, but it will also help other people. So I want it to be that way. I've given you hints on how to put it. Project title is required. You need to give a category and channel. So do what I say here. It needs an introduction. The supplies, this is important. You need to put there the materials needed, because when somebody wants to build it, the first thing they want to figure out is how much will it cost, what is needed to have this thing. So the supplies is important. When in doubt, look at some of just search for other people's work and try to sort of emulate somebody else's work. That's probably the best way to do this. But you'll see that normally people put supplies and then they go step by step. So in your steps, I want you to tell me about the support structure, joint design, actuators, sensors, programming, and so on. And don't start putting big chunks of code. It's better to upload them somewhere in the Instructable so people can download it. Now, the best way I can make you do this is, and I found this more effective in trying to throw it at you and tell you, come in 8 weeks and show this to me, is to have milestones. And I would like, and I would tell the TAs to grade you on these milestones, and they are spread out throughout the rest of the semester. So milestone 1, you're already on it probably. It's due tomorrow, March 17th. This is just looking for what is out there. Next week, there's no class. By the way, there's no class. And because spring break, there are no labs because the spring break. We'll meet the following week. Now, this is going to be a major milestone. This is where you need to figure out or sort of brainstorm a few questions, like what is the animatronics going to build? What are the interaction modes? What sensors you'll use? And this is I would say is the very, very important part, because this will determine how you will proceed with the build-up. So what I've done is I want to meet with each group in person. So I will set up a appointment slot on this link. So you have to go to that slot and figure out a time which works for you to talk with me. And when I talk with you, I expect you to show me what are your ideas for 1 through 6 through a presentation. Okay, so don't make it too long. Just make it like maybe 5 or 6 slides, based on the 6 points I put there. Okay, but I think that's important because I don't want you to do something overly complicated, which is the major cause of people not completing this on time. And I don't want you to do something too simple, which just misses the objectives of the animatronics. So I think it's important that you present to me what you are going to do. And then, of course, I understand that some things will not pan out and you might have to change, but I just don't want you to take the too extreme, which is too complex or too simple. Okay, so this will be in person through Zoom. I have the link. Okay, now there are milestones. There are 3 milestones, and they are like sort of trying to get you started. So create the chassis is the first one, programming the motors. So this is where you sort of get the motors and the sensors going, but you don't really mount it. And then more integration. And then the final one is week 6 from today, which is April 27, which is the last day of class, which will not have a class, but we'll have the demonstrations. We'll have them in my atrium. And I'll post more details. We'll have a table for you to set up. And then you can place it there, and I'll invite many people, and they'll come and see our animatronics, and we'll, of course, grade it at that time. Now, the report, which is basically the Instructable, is due a week after that. So I'm giving you a little bit more time. But this is something you want to remember, that your Instructables will look very, very good if you take some efforts in documenting your work. So what I suggest is when you build your animatronics, take a lot of photos. So milestone 3, take photos, take videos. Even if you don't use them, just take them and keep them, store them maybe in Google Docs. Do that for milestone 4, do that for milestone 5. Once you have all these things stored somewhere, when you go and write the report, the Instructables, it will be fairly easy because you would have the right amount of details to put in there. Okay, and the question is, how detailed should it be? Is a question you can ask yourself. If somebody is reading your website, your Instructable, can they use your instructions to build it themselves? If the answer is yes, with what you have in mind, then that's what you want to put it. If it's no, then you should probably beef it up, put more things. Okay, the final thing before we are done, the grading is here. You can see that I grade you based on the milestones, achieving the milestones. It's important that you keep track of these milestones and achieve whatever is set forth. That's about 40 points. The actual demonstration, this is on April 27th, is 30 points, where we'll check these things. And then finally, The last is the instruct tables, which is going to be 30 points. Okay, and then I've given you a lot of hints on what to expect, what not to expect. For some of you, this is probably one of the many projects you've already worked on, so you know how to work on projects. But for some of you, it might be that it's the first time doing something like this. And I've put some things to help you sort those things out. Essentially, the main thing I would hint at is that, and this is inevitable with all projects. Okay, you will make mistakes, you will burn out motors or sensors, you will fail. Failure is a part of building something like that. So what you want to do, however, is try to do these things as soon as possible, so that if you fail, something doesn't work, you have a chance to improve and fix those issues. So even though I've said milestone 4 is due in this week, milestone 5 is due this week, you are free to get started early on this and try to finish the project as soon as possible. You do not have to wait for the milestones to